So you already have a little bit of this, and I've reprinted some of it. I added some pictures and some additional text. We're going to talk about collection of fingerprints today. Then I have an activity for us.
Activity?
Yep.
Why are you wearing Christmas habit then?
She's wearing her somewhere. But it's also really hot there, so.
The bird hat actually pertains to the it doesn't. What? Bird hat pertains to the submarine you're judging.
Okay. So,
After November 18th. I was just kidding, that's fine.
we are talking about collecting fingerprints. We said that this was part of the crime scene investigation. We talked about the crime scene investigation in general. One of the activities is collecting fingerprints, obviously, and we need to know a little bit more about how that's accomplished. First of all, we have several different types of fingerprints, and the easiest one for us to see are the patent fingerprints. Patent prints are easily visible without any enhancement, and they occur because someone has stuck their fingers in something that outlines the fingerprint for them, like paint or blood. And you can see this would be an example of a patent fingerprint. And this would be how we would photograph such a fingerprint. We call this a one-to-one picture, where the dimensions of the picture itself are the dimensions of the actual fingerprint. So it would appear that the fingerprint is real size. Now, obviously it's enlarged here, but if I took this photograph out and I laid it on the table, the fingerprint would be the same size as a real fingerprint. Okay? So notice the information that's on here. We've got the date, we've got a case number, and we've got a reference number to the particular piece of information. Oh, hello. Stuck in. So that's a patent fingerprint. Okay. We also have plastic prints, and they're called plastic because we make an impression. They're also called impression fingerprints, but these occur when somebody presses a finger into some type of moldable material, especially wax or putty or butter. This leaves behind a three-dimensional impression of the fingerprint. You can see that here as well, right there. And then we have latent fingerprints, and these are not visible, but these are left behind when an individual touches the surface and deposits oils and other residue on the surface in the pattern of the fingerprint. These are invisible, and they require special procedures to recover. Okay, and you can see him recovering fingerprints that were previously invisible on the fender of a car there. Okay, search for fingerprints usually occurs in two phases. Normally, investigators will conduct a search for plastic prints or patent prints first because they can see them without any other enhancement other than maybe a flashlight. After this, a search for latent prints is conducted. And this occurs even if patent or plastic prints are found, because visible prints may not be from all the individuals in the crime. That wasn't nice of that to do. on. Let's say reconnect. Okay, and even if we do find paint or plastic prints, we need to stop it. Initially, points of entry or exit or areas around disturbed items are focused on, but then the search expands into additional areas if no prints are found. The type of technique used to find a print depends on the type of surface. And you're all aware that powders and chemicals are commonly used to enhance the visibility of fingerprints. You see it all the time on crime scene shows, but it depends on the type of surface the fingerprint is on. And we can actually collect fingerprints off of things like cloth or even very porous materials. But the problem that we have is that some of these methods have the ability to destroy the evidence related to fingerprints. So it's more common to search for fingerprints first using alternate light sources. And so the first thing we're going to do is we're going to look at the scene, if we can, with alternate light sources. So depending on the nature of the surface on which the print rests, light of specific wavelengths may allow us to visualize latent prints, whereas ambient light does not. So if I've got sunlight shining on something and I don't see the prints, depending on the type of surface, if I take a specific wavelength of light, like violet light or green light or orange light or red light, and these are lights of a specific wavelength. These are laser or LED devices. Or we might be able to use a filter that has several different wavelengths of light on it. We can collect this. So this is and you can see how interesting. So this is a tarp-like material, and it's got this little crossed pattern of the threads of the tarp in it. So this doesn't have to be a completely flat surface, but using this kind of an orange light here, we were able to see these particular fingerprints where we couldn't see them before. Okay? So alternate light sources help us. And that's an easy way to see latent fingerprints that we might not see with regular types of light. The other thing is, if you think there might be fingerprints like on a board like this or a wall or something like that, you can't dust the whole wall for fingerprints, right? You might need something to be able to shine on here so you can identify where the fingerprints might be, and then you can dust to bring them out a little bit more. Powders are used a lot. You see that, and we'll do this next week. Smooth, non-porous surfaces have been dusted with a variety of powders. So like a whiteboard, the wall's a little bit, well, that would be non-porous enough. Pieces of paper, metal, glass, these kinds of things. But a lot of things have been used to try to bring out these invisible prints. The powder's made of really fine particles of material that's dusted over the surface slightly, and the particles adhere to moisture and oil in the latent prints. Okay, so the particles literally attach themselves to the moist areas of these fingerprints, and then we can subsequently photograph or take the impression, remove the impression using a transparent piece of tape, and we'll do that as well. We'll take fingerprints and then we'll lift them using tape, and then we'll try to take some pictures of them. But anyway, compositions of fingerprint powders vary depending on the surface. They usually consist of something called a pigment and a binder. The pigment helps to provide contrast, whereas the binder helps the powder to adhere to the print. And commonly used pigments are carbon particles. What color do you think carbon particles are going to be?
Pink.
Green, white, or light colored surface.
Blue.
Well, we use it on white or light colored surfaces.
Black.
It's going to be black. Carbon's black, right?
It is?
Carbon is black,
I didn't know that.
You right.
right? What happens when you burn a piece of wood? It turns black, right?
Oh.
That's carbon, okay? Flakes of metal, including aluminum, zinc, and copper, can be incorporated into the powder. And so dark colored surfaces, mirrors, and metals, we can use this kind of powder on. A magnetic powder, it's applied with a magnetic wand. Some surfaces that might be especially useful on plastic or styrofoam or rubber. And then fluorescent powders, we're going to use where the print is difficult to distinguish from its surface, and we'll see some examples of that. And then some common binders are gum arabic, iron powder, and rosin. So these are the things that make it stick to the fingerprint. Okay, so that's powders. And if I scroll down, and where I talk about dusting, and this is how to. Dusting is the most widely used method for detecting latent fingerprints. It's suitable for hard or non-porous surfaces. We talked about the several types of powder, and then the developed print can be lifted by means of clear sticky tape and collected for analysis. Okay, and this is what that would look like. Okay, this is a person that's dropped a little bit of powder over the print, and then they're dusting it to kind of make it attached to the fingerprint and then scrape away the excess. And there's a fair degree of art to that, and we'll talk about that next week when we do this. We'll dust our own fingerprints there.
No.
Chemicals. So the good thing about dusting is that it doesn't hurt the fingerprint. We can still use the fingerprint for DNA purposes, right?
Yeah.
How many of you guys are on your phone right now? It looks like a couple of you are looking down at your phones. I'd appreciate it if you put them away. Okay, so chemical developers, the sweat that's deposited as part of your fingerprints contains amino acids. Okay, and they don't move significantly from where they're deposited, and if they can be visualized, they allow the person's fingerprint to be seen. A thing called ninhydrin is a material that's sprayed onto the surface, and it reacts with these amino acids to produce the ammonium salt. And you don't need to know this chemistry part here, of something called Rubin's purple and a clear purple color. This degrades in the presence of light and oxygen, so developed prints must either be protected from these or photographed soon after development. So we can use this, but we have to be quick about it. There are other compounds that react with amino acids to produce similar things, but they all have this problem that they degrade eventually. But the ninhydrin looks like this. Okay, it's got this kind of a deep purple color. So that's the ninhydrin. Reacts with amino acids, commonly used with paper and porous surfaces. It can be used after iodine fuming, but we have to be quick about it once it develops because it will degrade. Go back up here to the next thing, and actually let's go down to the staining more. One other thing that we will try to do, and I've never done this before, but we're going to try it next week. Iodine reacts with fatty oils from the finger to form a visible but short-lasting print. Works best for prints on porous paper. The print will fade over time, but as iodine does not alter the print chemically, we can reapply it if we need to. But it gives you this kind of a brown color. So we're going to try that next week. And then silver nitrate also is something that reacts with the chlorides in the skin. So we've got three different things here. We've got something that reacts to the amino acids. We've got something that reacts to the fatty oils. Okay, and then we've got something that reacts with the chlorides in the skin. And developed prints must be photographed immediately because the reaction will eventually fill the background. And you can see this here. So if I have some prints on a piece of paper, I can see that it brought these prints out. It stained these prints, but it will soon afterwards also stain the rest of the background. So these have to be photographed very quickly. And it can be used on paper, cardboard, plastics, unvarnished light colored woods. It's not useful on items that have been exposed to water. And then, oops, the last thing, the next to the last thing, cyanoacrylate. It's basically a plastic. 1982, Japanese scientists working on cyanoacrylates, the types of molecules used in superglue, found that fingerprints on one of the fume hoods they were using had been made visible by the fumes of the cyanoacrylate. Okay, so it seemed that cyanoacrylate had polymerized on contact with the residues of the fingerprints. Okay, so this vapor, this superglue vapor, latched onto the residue of the fingerprints and made it visible. It followed the lines of the ridges, and this technique is of particular use for rough, non-porous surfaces. The time it takes for the cyanoacrylate to condense on the print is fast, especially when heated. Durability of the prints is also positive. They're super glue, okay? So these fingerprints last for a long time, and though the cyanoacrylate polymer is colorless, it can be visualized more easily using powder after the fuming has been carried out. And the more recent the fingerprint, the more effective this method is. But you've seen them do this a lot on crime shows as well. And again, the fumes bind to the oil residues. This makes a white permanent impression that can be treated with powders or fluorescent dyes. And it's also easier for lifting, used for developing prints on non-porous surfaces such as metals, glass, plastic, adhesive tape, and firearms. And we'll actually be doing this in the hood in there. This works really well, and you'll be really impressed at how well this shows up your fingerprint. And this is kind of what the fingerprint looks like, literally super glued. Okay, so those are the ways that we're going to look at some things. So we're going to conduct a lab next week. We'll take our own fingerprints. Hi.
Hi. When you're done teaching, will you call me? I just gotta give you something to sign.
Okay. I can do that right now.
One, zero. What is this even called?
No, it's synthetic.
So what is
Okay, so we'll conduct a lab. We'll collect our own fingerprints on a couple of different things. We'll collect them on index cards, and we'll dust, and we'll try to stain them as well. And we'll try to stain them with a couple of different things, probably silver chloride and the iodine. And then we'll also put our fingerprints, at least one of our fingerprints, on glass. We don't want to do more than one or two because it's going to take too much of the material. But we'll do that, and we'll fume it with the cyanoacrylate. It's kind of interesting. The super glue will actually catch on fire if you just touch it with a ball of cotton. Okay, and so we use cotton in our process to help create the fumes. We'll use cotton balls, and we'll put the super glue in it, and we'll start to get fumes coming out of that from the. Don't try that at home. It's pretty dangerous.
You don't want to.
Huh? Yeah. You didn't hear it from me. So anyway, we'll do that, and we'll lift those prints with tape, and we'll try to transfer the fingerprints using the tape. And then, if we have time, we'll try to see if we can get clear enough prints that we can figure out whose fingerprints are on a coffee cup or something like that. Okay? Okay. So, for the rest of the class, I have an exercise for you. Let me stop this.
Or maybe we could do an easier one.